Hi, this is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, in our video lecture series, we are going to discuss about the topic acceptance angle and numerical aperture. So, already we are actually discussing in the subject optical and microwave engineering. So, this is the next episode, acceptance angle and numerical aperture. So, come, let's get into the topic. So first, before getting into the topic, let us see the need for this acceptance and angle and the numerical aperture. So what is actually acceptance angle? Why it is needed in when you are considering the optical fiber communication? See, in the name itself, you can understand that it's an acceptance angle. That means how much light the fiber can able to couple for communication. That is called an acceptance angle. So large large area of light, accepting large area of light, that means that there will be a effective communication will be possible. So this acceptance angle, which should be considered for the short distance communication or multimode fiber communication. So this is the importance of why we are going for the acceptance angle in the optical fiber communication, right? So, what is the actual definition for acceptance angle? The acceptance angle or is the maximum angle at which light can enter the core. Here, the core part is important. We already discussed fiber optic structure where we have two things which should be considered. One is a core, another one is a cladding. Where core is a important point, important thing where the light can be propagated, right? So here, which light can enter the core of an optical fiber and still be guided through the fiber by total internal reflection principle at the core cladding interface. So you can see the image. We can exactly understand what is actually acceptance angle. The red mark, that's the conical symbol which indicates the acceptance angle, where the blue pipe like structure which indicates the optical fiber with core and cladding. So light ray injected outside the acceptance cone will be refracted into the cladding or leak out. Light ray injected within the acceptance cone will remain in the fiber core. So this is actually acceptance angle. And the acceptance angle defines the limit for the incident angle that is measured from the fiber axis beyond which light won't be guided and will escape the fiber. So the formula for the acceptance angle, which is nothing but of sine theta A. So where theta is the angle, sine theta A, which is equal to NA. That is a numerical aperture that we are going to discuss in the forthcoming slide, which is equal to root of N1 square minus N2 square, where theta A is the acceptance angle and N1 is nothing but our refractive index of the core and N2 is the refractive index of the cladding. So where we know the core and cladding are the two important pivotal concepts which is there in the optical fiber communication. So, what is the significance of optical there is acceptance angle? So, the first thing is efficient coupling of light. So, acceptance angle determines how much light from the external source, that means light like laser or LED, like these are all can be considered as a optical fiber source, can be coupled into the fiber. So, large acceptance angle allows more light to enter, improving the coupling efficiency. And the next thing, system design helps in designing optical system for maximum power transfer, critical in choosing compatible light sources and alignment tolerances. Then next important thing is the transmission quality to ensure the those rays will undergo total internal reflection or accepted, maintaining the signal integrity. So let's see the classroom activity. Hope you see the image in the slide. So find out the three differences between these two images. We have already formed the groups. You find out the answer. You discuss with your team members and find out the answer. So let us see who will be cracking the answer soon, right? Okay, but here surprising thing in this image is there is no difference between these two images. But why I have mentioned, why I have asked the two difference means, see, whenever we are asking the question, you will be going to find the answer. Your mindset will first strike to find out the answer. But actually, we have to see the image. Whatever it may be, we have to clearly see the image whether we have a difference or not. So there is actually no difference between these two images. So let us resume the session. The next thing, already we have discussed about acceptance angle. The next thing is the numerical aperture. So, what is the need of this numerical aperture? Here, in optical fiber communication, the numerical aperture is a crucial design parameter. It directly affects how efficiently light from a source can be coupled into the fiber, how well the fiber guides the light, and ultimately how effectively the data is transmitted over a long distance. So, here in this image, this is the experimental setup to find out the numerical aperture for a light source. And the formula for numerical aperture, it is nothing but of numerical aperture, which is equal to n square core minus n square cladding, where n core, which is nothing but of refractive index of the fiber core, and n cladding, which is nothing but of refractive index of the clad surrounding to the core. And the importance of numerical aperture. So there are several parameters are there why we are considering this numeric aperture. First thing is light coupling efficiency. Next one is the ease of alignment and bandwidth and dispersion, then signal quality and distance. And so these are the types of fiber and numerical apertures with values indicated. So for step index multimode 0.20 to 0.50, gradient index 0.20 to 0.35, and single mode 0.10 to 0.15. So according to the typical numerical aperture range, there which is used in several applications, different kind of applications that is given over here. So thank you.